Hello, differential equations. I'm going to go over the study guide and answer all the questions in here. The Runge cutter problem at the very end I did in a separate video, but I will do all these other ones on here. Okay, so starting with just some simple initial value problems. So first thing you do is you need to kind of classify what's going on here. So as it is written, we got x prime plus x cubed equals 0. And it seems like, oh, I got an x to the third power, so maybe like Bernoulli. But then I'm like, wait a second. If I move this over to the other side and write this as dx dt equals negative x cubed, then I realize that this is actually just separable. So this is separable, and so I can write this as x to the negative third dx equals negative 1 dt. Then I can integrate both sides, doing the separable thing. This gets me x to the negative 2 equals, and then I'll just put the plus c on the right-hand side. So this is negative t plus c. Then we probably want to solve for x. And so this is going to be 1 over x squared equals negative t plus c. Solving for x gives us that x equals 1 over the square root of negative t plus c. And if I plug in 0, I should get 1. And so x of 0 equals 1 over square root c. So it looks like c needs to equal 1. So the final answer of this initial value problem is x of t equals 1 over square root of negative t plus c. Oh, sorry, but we got plus c. So plus 1. Plus 1, and that is the solution. Looking at this one, again, it will be separable. And so what I can do is I can write it as dx dt equals negative 4t over x, and then get the x's on one side, t's on the other. So this will lead to x dx equals negative 4t dt, integrating both sides. And I get x squared over 2 equals negative 2t squared plus c. Multiplying both sides by 2 gives me x squared equals negative 4t squared plus c, and then square root. So x equals square root of c minus 4t squared. And then what am I going to want to do? I need to plug in 0 and get 3. So it looks like x of 0 equals 3 equals square root c. So c has to equal 9. So the final solution is x of t equals square root of 9 minus 4t squared. So that's the solution. Finally, or not finally, now we have exact differential equation. Why do I know it's exact? Well, the fact that it's in y and x is kind of a dead giveaway. And then the y prime here, what we can do is we can rewrite it as dy dx, multiply by dx, and then it will be in the form that's familiar. And so I'm just going to do that now. So dx, and then I'm just going to call that dy, just by multiplying everything by dx. And so this is the form we're more familiar with. And then what I want to do is I need to make sure if I call this m and I call this n, I need to make sure that m sub y equals n sub x. I need to check that to make sure it's exact. If I take the partial with respect to y on the left-hand side, I get cosine x plus 2x e to the y. And if I take the partial with respect to x on the right-hand side, I get cosine x plus 2x e to the y. And so, yep, it's checked, it's exact. So what we'll do is we'll take we'll integrate m dx first. And so what's that going to equal? That's the integral of y cosine x plus 2x e to the y dx. Integrating that with respect to x gives me y sine x plus x squared e to the y. And then I need to take the partial of that with respect, oh, and then plus some function of x, plus some pure function, sorry, of y. Pure function of y. And then what I do is I take the partial of that with respect to y. So partial of that with respect to y, what will that be? Let's see. So partial of that with respect to y of y sine x plus x squared e to the y plus some function of y. What will that equal? Take the partial with respect to y, I get sine x plus x squared e to the y plus f prime of y, and I set that equal to n. So sine of x plus x squared e y minus 1. So that means f prime of y equals -1, just by canceling out both sides. So f of y equals -y. So that means our function that satisfies everything is going to be y sine x plus x squared e to the y minus y, so that equal to a constant c. And then the last step is to plug in that into here to solve for what c is. And if you plug it in, you will get, so plugging in 3 for x and 0 for y gives me 0 plus 9 minus 0 equals c. So c equals 9. So the final solution is y sine x plus x squared e to the y minus y equals 9. That will be the implicit solution, and we can just leave it like that. That's that one. This one, because it has a y here and a y cubed here, this y cubed and y is making me think that it's going to be a Bernoulli type system. And so to get it into Bernoulli form, so I actually don't remember what Bernoulli form is. Bernoulli form, I guess it's in here. Bernoulli form is at the top. What is it? Bernoulli form is when you have something, the derivative equals some function of t times x plus some function of t x to the n. So let's write it in that form. And then it will boil down to that this will be what you get in v prime. And so let's do that. So writing that, you get y prime equals minus 2t y plus y cubed, and then I have to divide both sides by t squared. What does that simplify to? So this equals what? -2 over t y plus 1 over t squared y cubed. So that's in Bernoulli form now, where this thing is p of t and that thing is q of t. So now we're ready to rewrite it. So you do v equals y to the, you take the highest power, this n, and then you do 1 minus that. And so to the -2. If you put in that substitution, you get that v prime equals 1 minus n. So it's going to be -2 times p of t, which is -2t, v plus -2 t to the -2, and then that's just q. So now this is a linear differential equation. We can put it all together and you get, that's gonna be 4. So v prime plus 4t to the -1 v equals -2t to the -2. So now I need to do the integrating factor. So mu, the integrating factor, is the e raised to the integral of 4t to the -1, which I believe is going to be ln of t. So it should just be I think this is going to be 4. Wait a second. No, that's not right. So this equals, oh, it's going to be 4, t to the 4th. It'll be e to the ln of t to the 4th, because the 4 becomes a multiplication up there, and so this is just t to the 4th. So that's our integrating factor. So I multiply everything, I get t to the 4th, which is the integrating factor, times v equals the integral on the right-hand side by multiplying by t to the 4th, negative 2t squared dt. Then what does that become? The integral of that becomes, and where did this come from? I multiplied q of t times the integrating factor t to the 4th. And so that's how I got t to the positive 2. That becomes negative 2/3 t cubed plus c. Now the final step is next step is to solve for v. So v is going to be negative 2/3, and then t to the 3rd divided by t to the 4th is t to the minus 1, and then plus c t to the minus 4. Final step now is to plug back in what y is. So y to the minus 2 is equal to that. T to the minus 1 plus c t to the minus 4. And then we could solve for what c is by plugging in the initial condition that y of 1 equals 2. So I could plug in, so y of 1 equals 2. So plugging in 2 for y, I get 1 over 4 equals negative 2/3 plus c. So it looks like c is going to be 1/4 plus 2/3, which is, what is that? 8/12 plus 3/12, 11/12. So c equals 11/12. And then you can solve for y. So y equals 1 over that and then square root. So that's a pretty disgusting thing, but is solvable. So it's negative 2/3 t to the minus 1 plus 11/12 t to the minus 4. And you can be sure that if you plug in 1 for t, you'll get negative 2/3 plus 11/12, which is 1/4. Square root of that is 1/2, and whatever that is 2. So this is indeed our solution. Okay. Consider a pond that initially contains 10 million gallons of fresh water. So fresh water means the concentration at time 0 is 0. Stream water flows in with arsenic at a rate of 5 million gallons per year. So this is flow in rate. An outflow stream leaves at the same rate. So flow out is going to be the same. Flow out is the same. The concentration of arsenic is given by 2 sine of t grams per gallon. T measured in years. I can already tell that I'm going to need more space, so I'm going to have to add a page here. This is not all going to fit. Okay. So this is going to be my concentration. Concentration at time t. Let Q of t be the amount of arsenic. So we want to do, how do we want to do this? Write a difference equation that describes the amount of arsenic in pond. So the amount, so Q prime is going to be rate in minus rate out. And rate in is going to be equal to the flow rate in times concentration. So for us, that's equal to 5, and we have to be very careful with the units. It's millions of gallons. So that's 5 times 10 to the 6. 5 times 10 to the 6 gallons per year times the concentration, which is 2 plus sine of t grams per gallon. And so this will tell us how much arsenic is getting in per year, because the gallons cancel, and so you get grams per year. The rate out is going to be the flow rate out, which is 5 times 10 to the 6 gallons per year, and then times the concentration, which is the amount of arsenic, Q of T, over the volume, and the volume in this case is 10 times 10 to the 6th, or I guess I can show you this 10 to the 7th for these, right? Because it's 10 million. So 10 to the 7th. And that's grams per liter. Grams per gallon. And so that, I believe, so Q prime then, Q prime is going to equal 5 times 10 to the 6th times 2 plus sine t. And then this cancels with that, and you just get 1/2 plus 1/2 Q. And so, yeah, that's not too bad as it's written. The main issue is this kind of 5 times 10 to the 6th is a little annoying. And so I recommend using a substitution. So to get a simpler DE. So what was the idea here? So this implies that Q is actually equal to 10 to the 6th times little q. So wherever there's a big Q, we can replace it with that. And that also means that Q prime is equal to 10 to the 6th Q little prime, just taking with respect to T, the constant comes for the ride. So let's put all that in. So we get 10 to the 6th Q little prime equals 5 times 10 to the 6th. Actually, it's going to be 10 because I'm going to just multiply by 2. So it's just 10 to the 7th. 10 to the 7th plus 5 times 10 to the 6th sine of t plus replacing q with this gives us 1/2 10 to the 6th little q. And so the reason why this is nice is because there's a 10 to the 6 here, 10 to the 6 here, 10 to the 6 here, 10 to the 6. We can divide everything by 10 to the 6th. And what are we left with? We're left at q prime equals 10 plus 5 sine t. And then this will be 1/2 q plus 1/2 q. And so q, you can kind of think about q as the amount of arsenic in like megagrams, like 10 to the 6 grams. So it's just like kind of a different unit, but and so it just simplifies the equation a lot. And so that's our differential equation. We can find q from that. And then our initial concentration is that going to be the q of 0, 0. So q at times 0, the amount of arsenic times 0 is 0. And so this is a first order linear differential equation. And so we get in the form to do an integrating factor. And so you get q prime minus 1/2 q equals 10 plus 5 sine t. Oh, I can already tell this is going to be disgusting because I'm going to have to integrate. I'm going to integrate the integrating factor will be e to the negative 1/2 t, and I'm going to have to integrate that times sine of t, which is, woo boy. Okay, this is going to be fun. Okay, let's do it. Integrating factor mu of t is just e to the negative 1/2 t. So the left-hand side becomes e to the negative 1/2 t times q. The right-hand side becomes the integral of 10 e to the negative 1/2 t plus 5 e to the negative 1/2 t sine of t dt. So I will just say here right now that this integral is going to be much harder than an integral that you'll have to do on the exam. This one is a pretty fun one, but is hard. So what does this equal? So the left-hand side is still this e to the minus 1/2 t q. The right-hand side will become dividing by negative 1/2 is multiplying by negative 2. So negative 20 e to the minus 1/2 t. And then I have to do integration by parts for this. So let u be, I don't know, 5 e to the minus 1/2 t. Q du will be, you have to multiply by -1/2, so -5/2 e to the -1/2 t. dv is sine of t, which means that v is negative cosine t. And I'm going to do it one more time. So what does that all equal? -5 e to the -1/2 t cosine t minus minus, so that's just going to be plus 5/2 e to the -1/2 t cosine t. So then I have to do integration by parts again. But this guy, so we'll come back to that. Let's just do the integration parts again. So u is going to be 5/2 e to the -1/2 t. du is going to be -1/4 e to the -1/2 t. 5/4, sorry. Why 1/4? 5/4. I should move that over so it fits. Move that over. dv is cosine t, so that means v is sine t. Okay, so what the heck do I get? I get -5 e to the -1/2 t cosine t minus 5/2 e to the -1/2 t sine of t. And then it's going to be some constant times what we started with. -5/4, it looks like. Minus, and then I'm going to put the minus, so it's plus 1/4 of 5e to the -1/2 t sine of t. It's minus. Oh, but then I have to distribute. I always forget this minus. This minus also has to distribute, so that actually should be minus. Be very careful. Okay, that is minus. And so I have 1/4 and 1. So this is that thing where this is the original integral, and I have to add. So this is all like a dirty aside, but this aside. So I have to do that. The integral of 5e to the -1/2 t sine of t dt equals this stuff. So -5e to the 1/2 t cos t minus 5/2 e to the -1/2 t sine t. And then I'm going to add 1/4 of it. So 1 plus 1/4 gives me 5/4. 5/4. And so I get to divide both sides by 4/5 to get the answer. And so that gives me that 5e to the -1/2 t sine t dt equals, and the reason I got that is because I added this 1/4 to the other side to get a 5/4. And then it equals, dividing by 5/4 gives me -4 e to the -1/2 t cos t. 5/4 of this will be -2 e to the -1/2 t sine t. Wowza. That was a lot. Okay. I believe that's correct, though. Let me think about this for a second. Yeah, I think so. Okay, let's put it all together now. So that's just the aside. Now I need to plug this here. And so you get that Q is equal to, and everything has an e to the -1, and then there's a plus c too. There's a plus c over here too. Everything has an e to the minus 1/2 t, so I just multiply everything by e to the half t, and I get negative 20 minus 4 cos t minus 2 sine t plus c e to the 1/2 t. Oh man, that is a doozy of a problem. And so I want to plug in the initial condition that q of 0 equals 0 equals negative 20 minus 4 minus 2, 0, that's a 0, plus c. So it looks like c is going to be 24. C equals 24. So q of t, the final answer, is negative 20 minus 4 cosine t minus 2 sine t plus 24 e to the 1/2 t. So I will say it again, that this mixing problem is way harder integratively, like the integral is way harder, but the idea is good. So how do you get the rate in, how do you get the rate out to set up the differential equation? It's a linear differential equation. Next, we have a logistic growth model. Why do I know that? Because there's a p here and a p here. And the way it's like rp1 over minus p over k. That's how can I know. The phase line, so when is this 0? So the idea is you set this equal to 0 and you get p equals 0 or p equals 5. And so a phase line for that's really chill. P equals 0, p equals 5. And then I plug in slopes to see if they're positive or negative. If you plug in a number that's smaller than 0, for instance, negative 1, that's negative. And then that will be positive. And so positive times negative is negative. So the arrow goes down. Then if I plug in a number like 1, positive, and then positive gets me positive. And if I plug in a number bigger than 5, I get positive times negative is negative. So p equals 5 is sink. P equals 0 is a source, or is unstable, and then p equals 5 is stable. Sink, you can write stable if we want. Unstable. If p equals 0, what happens to the population in the long run? And so remember, because the p equals 3 starts here, it's going to go up and it's going to eventually hit the carrying capacity. So p of t will approach 5 as t goes to infinity. So in the long run, it goes to 5 because it's going to approach that equilibrium. Great. Make a slope field for x prime equals t minus x in the following region using isoclines. And so let's make a little table. So to make the isoclines, let me make 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And I would tell you probably what slopes to use for isoclines. So let's use slopes -2, -1, 0, 1, and 2. So those are the slopes we're going to use. So we set those equal, and so you get t minus x equals -2. So then you get x equals t plus 2. That's going to be the isocline for that one. And then, yeah. And then you will graph that. And so if this is our t-axis and our x-axis, so x equals t plus 2. So that's this line and a slope 1. And so it will look like will look something like that. And then along that line, the slopes are -2. And so -2 slopes. So like at this point, the slope goes down 2. And so it's something like that. And then this point it's -2. And so the slope is always -2 along those lines. So -2, -2, -2, something like that. Let's do t equals. So then the next one for t minus x equals -1, you get that x equals t plus 1. And so that's going to be this line. it's going to be parallel to it. And along that, the slope is a little bit flatter. It's going to be -1. And so it'll be like, like -1, -1. It's actually going to be perfectly perpendicular because that had slope 1. And so they're perfectly perpendicular. And so that's what the isoclines for those look like. And then we get x equals t when if the slope is 0. And so that's going to go through here. So you get these lines that are all parallel. And then along this isocline, the slopes are all 0. So they're just flat. And then the next one will be x equals t minus 1. If you plug equal 1. And so that's going to be this line. And so you can kind of tell what's happening, hopefully. They just get a bunch of parallel straight lines, and the slopes decrease. Or sorry, actually, they're increasing as we go along them. So these ones are going to have slope 1, which actually go exactly on this line. They will match that line perfectly. And then the last isocline will be x equals t minus 2. So that's the last isocline. These are supposed to be parallel, but my graph is not super good. And so on these lines, we have slope 2. And so slope 2 goes a little bit steeper, And so that's the idea. I mean, it doesn't, not a super great picture, but the idea is you can tell slopes on here are going down and they kind of taper and they go up and then they go up. So solutions kind of do that. And so I could ask you to maybe draw a possible curve that goes on that, but I don't know. These are things that computers do much better, but I just need to know that you understand what the computer's doing. And so this is how I test it. All right, let's do another slope field. For this slope field, what's going on here? Plot slope field for x prime equals x times t in the following region. And so there's just gonna be 3 points. So just the integer points. So this is like the level of being able to do a slope field that I would ask you to do on an exam to like actually brute force it. So there's just going to be 9 points that you have to graph. And so at all the 0 points, it's 0. So it's 0 here, 0 here, 0 here, 0 here, and 0 here. And then if they're both +1, then the slope is 1. If one's positive, one's negative, it's -1. If they're both negative, it's +1. And if one's positive, one's negative, it's like that. Kind of looks like a circle a little bit. And so you could plug in the values to make sure that those are right, but that's what it'll look like. And then that is it. All right. Good luck studying. If you have any questions, feel free to reach out. Okay.